So now we want to talk about a composition of a trig function and its inverse. And we've talked about this before when we worked with inverses, but because of the restriction, we have to be a little bit careful. Okay, so we're going to start with, if I have the sine of the inverse sine of x, what does that equal? Well, originally you might want to say, okay, it's going to be x because they undo each other, and so I get back to x. And that's true, but we have to know where the restriction is. Okay, 4. And then what is happening here? Inside the parentheses, we're doing an inverse, right? And so think about the output of a sine function. That's between -1 and 1. So my x has to be between -1 and 1, okay, in order for that to be true. And then cosine, we can do the same thing. Inverse cosine, well, I put it in extra parentheses, equals x. And that's got the same range on the cosine function. So x has to be between -1 and 1. And then tangent, okay, but remember for an inverse, you can have it be, anything, any real number. So it's going to be for -infinity, x is between -infinity and infinity. Okay? All right. So that was that part. Now we're going to go the other way. So you could draw a dotted line or something. But inverse sine of sine x. Okay, so think about what's happening in here. Here you're being given an angle, right? And so we know we want it to be equal to x, but what's the restriction? Well, the restriction has to be that that angle has to be between -pi/2 and pi/2. And then for cosine, the restriction has to be 0, x has to be between 0 and pi, including 0 and pi. And then for tangent, tangent has to be, your x has to be between -pi/2 and pi/2. But this time we don't get to include the ends, right? Okay. So this is handy information. It's in a box in the book as well. So you just have to remember the restrictions.